Guys, this is Katechi, and today we are going to continue with our lesson on logarithms. Okay, and the topic for today is properties of logarithms. Okay, in case it's your first time watching this channel, then I'll plead that you go back and check out my other videos, my other two videos on logarithms, where we talked about an introduction to logarithms and then some rules in logarithms. Okay, but before today's lesson, let's do a recap. So we talked about the intro to logarithms, and we said that if in case you are given an exponential equation, say b is equal to a exponent n, okay, you're supposed to make n a subject, or you want n to stand alone, where n is the index and a is the base. Okay, then you have to write it in this form, that you find the logarithms or the log of both sides. Okay, so log b to the base a would then be equal to n. So this is the logarithmic form. Okay, let me highlight it for you. Okay, so that's that nicely. Okay, but what if you are given a logarithmic expression and you're supposed to express it in an exponential form? Then remember, this is our index. Okay, in logarithm, this becomes the index, this becomes the base. So we are saying that this number b will be equal to the base and then the index. Okay, or simply put, you can just simplify it this way. We have a here and we have n here, so you move the a to shift the n up. Okay, so and then we forget about the logarithm, so it then becomes b is left on the left hand side, so b will then be equal to a comes to the right hand side and pushes the n up. Okay, so b is equal to a exponent n. So that's that. Okay, so next on the list is the rules. So the rules we talked about, rule 1, which says that log of m times n to the base a is equal to log of m to the base a plus log of n to the base a. Okay, remember they must be in the same bases. So let's solve a question under this. You're supposed to simplify. Log of 3 plus log of 4. And please note that whenever you see an expression in the logarithmic form where the bases are not written, then we assume that it's in base 10. Okay, so kindly note that. So this is just equal to log of 3 times log of 4 all to the base 10. Okay, and this is just log of 12. So that's the final answer. Then we look at the second law, which says that log of m over n all to the base 10 is just log of m to the base 10, or to any base, let's say a, minus log of n to the base. This also they must all be in the same base. Okay, so solve simplify log of 6 minus log of 2. So this is just equal to log of 6 out of 2 all to the base 10. So this is just log of 3. So that's the final answer. Then we also look at the third law. Okay, before the third law, let's solve this equation. Let's solve this problem. Log of 2 to the base 10 plus log of 6 to the base 10 minus log of 4. Okay, minus log of 4. So this is just, we have to multiply and then divide. Okay, so this is division, this is multiplication. So this is also log of, because they are all in the same base, we can express it as log of 2 times 6 divided by 4 all to the base 10. So this is just log of 2 times 6 out of 4 all to the base 10. Okay, so when you simplify this, you're going to get log of 3 as your final answer. Okay, so then the third rule, we said that for a situation where we have this expression log of say n exponent b to the base a, okay, it is just b times log of n to the base a. Okay, so you just bring the b to this side to multiply the whole expression. So and I proved this in the previous video. Okay, so we can move to today's lesson. Okay, let me give an example under this. An example, we are supposed to express this in the logarithmic form. Let's say log, okay, you're supposed to simplify log of say 125. Okay, so this is just log of 5 exponent 3. Sorry, I'm supposed to express I need 5 exponent 3. Okay, so this is just the same as 3 log 5. Okay, so let's move to today's properties of logarithms. So the first property, we are saying that the logarithm of any number, okay, to the base of the same number is 1. What do I mean by that? What I mean is this: log of say a to the base a is 1. Okay, so the logarithm of any number, okay, the logarithm of any number to the base of that same number is 1. So I can there's a way of proving this, but I don't think it's important now. Okay, so let me put it this way. That is the logarithm of any number to the base of the same number. There is just 1. Okay, so what's the second law? Yeah, so the second law states that the second property, okay, is just log of say 1 to the base to any base is 0. So the logarithm of 1 to any base is 0. Note that is the logarithm of 1 to any base is 0. Okay. So, and you have other properties, okay, but they were derived from this first property. That is log of a to the base 1 over. What do you think this will be? So let's derive it. Okay, we know that 1 over a is equal to a is per negative 1. Okay, but I can also express this in another form, or make a the subject, make a stand alone. So I can also say that 1 over a exponent negative 1 is a. Let's see if that is true. We know that 1 over a is the same as a is per negative 1. So a is per negative 1, all is per negative 1 is equal to a, because negative 1 cancels. Negative 1 times negative 1 is just 1. Okay, so we have our a, and this is equal to a. So we are saying that log of a to the base 1 over a is equal to log of 1 over a all is per negative 1 to the base 1 over a. And we said from the third law that if you have something like this, you just bring the exponent to this side and just multiply by a. So this is equal to negative 1 times log of 1 over a to the base 1 over a. Okay, And when we have this, okay, the logarithm of any number to the base of that same number is just 1. So this is equal to negative 1 times 1, okay, and this is just negative 1. What if we have it in the other form, such that log of say a to the base 1 over a, sorry, that is log of say 1 over a to the base a. This is the same thing as I said, that the logarithm of any number, okay, to the base of the inverse of that same number is just negative 1, okay. So you can put it in writing. So we can also prove that, okay, by saying that we know that 1 over a is equal to a minus negative 1, okay. So log 1 over a to the base a is just log a exponent negative 1 to the base a, okay, and this is equal to log negative 1, this will be equal to negative 1 log a to the base a, and this is just 1, so it's equal to negative 1, and the final answer is just negative 1. You can try this with values, okay. Example, log of 0.1, okay, it should be negative 1. Or example, another example is log of 5 to the base 1 over 5. This is negative 1. This is just this is base 10, and this is 1 over 10. So the inverse. Thank you very much.